Hey people, today I'm here in the civil engineering lab at Universidad de los Andes in Chile, and behind me you can see my HPC cluster Esmeralda, the one you maybe saw a video from a few years back where I explained the rationale behind this setup. Today I want to talk a little bit more about the software stack I'm using to run this cluster. But before that, let's do a real quick tour of the cluster. When you log in to Esmeralda through SSH, I'll show that in a minute, you come into this node over here, which is the login node called Esmeralda. Right next to it is Kraken. This is our storage node. It has a RAID, a large RAID and some fast disks where we do some long-term backup storage. And pretty much all the rest is compute nodes. They are labeled from 1 Roman to 18 Roman, so it's 18 compute nodes. And right next to it is Iquique, which is a workstation that's connected to the same local network, and it's meant for visualization. So we use this to visualize models without having to transfer large amounts of data to our notebooks and everything, so we can have everything on site. Everything happens through this QNAP fast switch array. So it's basically 3 switches. These on the regular Ethernet cables, I can do 2.5 gigabits per second. And in these SFP Plus cables, I can do 10 gigabit per second. And you can see one of these fast cables goes into Kraken and another one goes into Esmeralda. And the rest are connected to bridge the 3 switches. One final thing here is this handy dandy screen I have over here. It's usually showing the real-time monitoring of the building where this cluster is housed. I have 5 acceleration sensors placed at different locations, and we're continuously monitoring, and we're going to do some model updating with that in the future. But when I'm not doing that, I can use this monitor to quickly connect into each of the nodes that might be having some issues and get a user interface for that. So it's fun if you pair that with a nice set of wireless keyboard and mouse. You're all set for administration. So this is a very comfortable setup. It's a fast setup. It's a cost-effective setup. So I want to show you now how I use it, how it is set up from the software point of view. So these workstations are currently running Ubuntu Linux 2004, which, as you may know, is coming up to the end of life support for the LTS distribution. So I might need to think about moving into another distro, and I think I want to move away from Ubuntu. Just I haven't figured out what into yet. But that's a setup I have. Let's go into this scene over here, and what we can do here is we can log into Esmeralda. So logging into Esmeralda, I'm gonna log in as my regular user, which would be like this. You are greeted by our national Chilean hero, Arturo Prat, which is the captain of Esmeralda. And you have that nice, and you have some info here, which is mostly updated. And what I can see, one of the main things about one of these HPC clusters is it's the scheduler. The scheduler lets you tell the cluster what needs to get run, and the cluster would manage where it gets run. So let me show you what's going on right now. Right now, this is running at full capacity. If I do SQ, like so, I'll see what's going on. En Morabo, that's Nicolas, that's my PhD student that is running some huge DRM-based nonlinear analysis of some tall buildings where all sorts of nonlinearity is going on, and we're taking a look at stuff that's performance stuff that's going to come out of that. And we can see that he's using all nodes through 1 to 18. Now here, this is the queue. This is the queue of the Slurm scheduler. So you can see everything that's going on. If I queue something else, it will go into a pending mode. And you can see here how much time each of the jobs has been running for: 4 hours, 3 hours, 9 hours. And look at that. There's one pending one. This one is for my other PhD student, Patricio Palacios. And oh, look at that little thing. He's running one of our models for the Large Hadron Collider at CERN. So that's pretty awesome. And he's requested 10 nodes for that. So all of Nicolas's jobs are running on 18 nodes. Each of them is using 16 cores per node. And when enough of those are are over. So I need 10 free nodes. Patricia's job is gonna kick in and gonna run on those 10 nodes. So this is the scheduler. I can take a look at some other stuff that's going on. S-info will give me general information about the cluster, and 18 nodes are in a mixed state, which means all of the cluster is being used right now. This Slurm is the basic thing you want to set up for a cluster like this. Slurm is a scheduler, as I already told you, a job scheduler. So you'll tell the scheduler how much resources you want to allocate and what do you want to run on those resources, and the scheduler will do its magic. Slurm is basically used on all supercomputers in the world, most of them, but the top ones are using Slurm. So this little piece of software actually scales from something modest like this to the really big data centers. So I'm happy to be one of them. So what else can I show you about this? Let me show you real quick what a Slurm script looks like. So if I have one, let's see here. Let's take a look at this one. So this is one I'll use to run OpenSeas. Real quick, run.sh. So this is what a Slurm script looks like. So it has a header where each job gets a name, and the number of nodes that you request, and the number of tasks per node that you need to run, where you want your output to go, because you can't have the console open all the time. So you need that text output that you usually get on screen to be redirected to some other text file. So that's the name of the text file. And then right after that is everything that you wish to run. And the main line here is MPI run OpenSeas with an input file. If you wanted to run something in Python, you would replace probably this with Python, and that would be your Python script and some arguments possibly. You can do a lot of stuff with these little Slurm scripts right here. Anyway, so how do I get this set up? Let's go into the web browser. And I'll look for my own GitHub. So github.com. Let's close this here window over here. How you can see marvelous hyperland. It's fun to work with that. So among my repositories, you can look for Beowulf installer. So Beowulf installer is a script, basically an Ansible script that automates the setup of a cluster such as this. And you can find it's been online for years now, 4 years, actually for 4 years. And it's a project we did back with students here of computer science in Universidad de los Andes in Chile. And its purpose was to set up a cluster like this in the easiest way possible for me. So you feel free to check it out. What I want to show you right here is the stuff that it's made out. So basically, running Ubuntu 22.04, interconnected via Ethernet with a switch or a router. So the machines must be able to see each other. Our setup is with static IPs, which I set up by myself in the command line. So it's all static. I don't have a DHCP, which would be a nice option, but it's not needed for a scale like this. I can manage it all by myself. And we have this software stack, Slurm. We have PMix, OpenMPI. BigFS is a distributed file system, which we were thinking about using in the beginning, but we didn't end up using it. We're just using NFS over here. And this is the big player, Ansible, which automates a lot of the administrative tasks. So Slurm is the workload manager that scales from this all the way up to the largest clusters in the top 500. Let's see, top 500 supercomputers. I think this had some information about the scheduler. Let's see real quick. Resources top 500 in November, this one. So let's see, El Capitan is the leader right now in the Department of Energy in the United States. And does it say something? It doesn't say something about Slurm, but anyway, all these big ones really use Slurm. Let's see if we can really quick look. El Capitan supercomputer scheduler. What's a scheduler? What is your scheduler? Come on, man. Show me real quick with the power of the interweb. Our internet is super slow today. Jobs are scheduled per node. What are you doing here? Slurm? No, not Slurm. What are you using for schedule? Good sketch. Through Flux. Actually, they're using Flux. They're using something different. So that's fine. New stuff coming up. We'll have to take a look for the next iteration. Anyway, I don't want to waste too much time on that. Slurm is the basic thing that I'm using for scheduling my jobs. Emix is a programming interface. Basically, it lets OpenMPI, which is the basic paradigm for parallel computing on a distributed system such as Esmeralda, to talk with Slurm in a nice way. So this is something in between that as a user, or even as someone who has to set up a system like this, you have to get this done. It's something that you have in between, but you don't worry about it once you have it there. And this is the big player, OpenMPI. OpenMPI is an implementation of the message passing interface that is basically a distributed computing programming paradigm, which basically uses message passing to coordinate communication between processes. And this scales from regular laptops such as this one that have more than one core to something as complex as this. And it's used all around. And finally, the last one is Ansible. Ansible automates stuff for your cluster. So let me show you a little bit about the installer prerequisites. Of course, at this point, Ubuntu 20.04 LTS beta. If I move into some new OS, I'll have to update this to a new OS, but I know this to work. And at each node, you should install Ansible, and you should have SSH access to each of this node from the root node. And of course, passwordless setup, unless you want to be manually inputting some SSH passwords each time. And then you just run this Ansible playbook, main.yaml, and it goes ahead and installs everything. So let's take a look at what's in that main. You'll see it's very simple. APD, there's a script to install the master, and there's a script to install a compute node and the compute install. So let's take a look at those scripts real quick. The master should be pretty complex. So for example, some things, it's going to create the directory for the source code, and then pmix, opt pmix, and then you extract the pmix installation, which should be downloaded before, and then you compile it. So this takes care of the compilation of everything. Managing a cluster, you want it to compile as much as possible so that you can exploit the performance of the cluster as much as you can. And then you go ahead and install Slurm, and you extract Slurm, compile Slurm, copy. This is very straightforward. Like you just run this, and it just gets going. Let me show you some other stuff. Manji, all that stuff. This is what happens in the basic, in the master node. It's going to compute all the configuration files, and then those are going to get propagated into the compute nodes. So let's say BT, for example, install compute. This should be a huge apt. So BigFS, this one we're not using. I'll show you my NFS setup in a while. And then you install some stuff which is needed for the compilation, and then that's it. It's not a lot, actually. It's not a lot. That's what you need from APT. And then compute install.yaml. What are we going to do there? Basically propagate the configuration. So install pmix again, install Slurm. Every one of the compute nodes is going to have its own Slurm compilation there, but we copy the slurm.conf from the master, which is the one that aggregates everything. Basically, that's what happens. And once you've done that, you'll get something like this. So I'm going to log in as a master now. So now I'm not in my regular account. I'm in the administrative account, and let me show you some of the stuff that I have here. Here in admin tools, I have this handy dandy little folder where I have some scripts where I do some of the administrative work. So if I need to bring a node down, I'll run this script. If I need to restart a node or all the nodes, I'll use these scripts over here. Let's show you real quick. what that looks like. We start, for example, we start slurmd node sh is just issuing a system control command through SSH. So I'm running in like brute force SSH with root access from the master. So if you get access to the master node, that means you get access to the whole thing. Now you can't get access to the master node because I have a SSH set up to not allow root password login, and we're using strange ports and all sorts of stuff to prevent people from hijacking the cluster and start mining Bitcoin or something. And so this will just issue slurm commands to restart a node. The other one I use here, I often have to mount stuff. Okay, let me show you the file system. So this is what the file system is looking like currently on Esmeralda. So we have a dead man's chest. Dead man's chest is where all my users are located. So my home folder, if I take a look there, everyone's folder is set up to be running there. Dead man's chest is a fast M2, it's a 4 terabyte M2 drive that is located on Esmeralda. So all home folders are on Esmeralda, but they are shared to the login node, to the compute node, sorry, through NFS. So if I take a look, let's log in into, let's say, node 1. Node 1 is running crazy right now. So if I go top, I should see OpenSea's MP running like crazy with 100% CPU usage across 17 processes, because the base one of OpenSea is another one. So anyway, over here, if I do df, you'll see that Deadman's chest is mounted through NFS into this node. So this makes it easy that people manage their home folders. You log into Esmeralda, you have your home folder, and this home folder gets replicated through NFS into the other nodes. Another thing you can see here is a Squid chest, which is a little drive that is in Kraken, but the big one is Kraken's chest, which is the drive located here in Kraken. And this one is a 11 terabyte drive, RAID drive that is actually 83% capacity right now. And that is pretty much it in terms of setting up something like this. I obviously have more shares. You can see NFS share. This is where I store software. So for example, my OpenSea's versions are compiled here, and they are exposed over here in the bin directory. You can see we have links to a lot of stuff that is needed, HDF5 stuff, OpenSea's MP stuff, run Jupyter, which allows me to create Jupyter notebooks inside the cluster, SW4, which is for seismic propagation software. And what else is in here? You can see in software, you can see my stuff. You can see Shaker Maker over here, Speed. These are for seismic stuff. And the rest is OpenSeas and some linear algebra stuff. And yeah, that's pretty much it. All I'm running. These days, I'm going to be installing Phoenix, another finite element program, which I expect to be running in the cluster to do some actually volcanology, which would be fun. Anyway, this is the tour of the software tour of the cluster, and I hope. Look, if you want to use this, feel free to reach out if you have any trouble. I can try to lead you, but this is very specific, and you really have to get to know each of the tools. Now, AI nowadays helps a lot in setting up something like this and debugging and getting stuff to work. Anyway, I'll see you guys next time.